Good afternoon, everyone, and welcome to reInvent. I hope everyone had a safe Thanksgiving, and I hope everyone survived their Black Friday and Cyber Monday shopping days. Just out of curiosity, a show of hands, who here had family or households that took part in the Friday and Saturday and Sunday and Monday sales? Anyone here? All right, couple. Keep your hands up if you shopped online. Okay. Keep your hands up if you shopped on Amazon. All right, a couple of you. Well, thank you for that. This story is going to be about Amazon today. And I'm Gary Galinsky. I'm a solutions architect with AWS. And I actually support Amazon as a customer on AWS. I'm going to be joined today on stage by Rachel Cook. She'll be on in a couple of minutes. And Rachel is the director of repair, maintenance, and engineering, reliability, maintenance, and engineering, my apologies, at Amazon. We're going to be talking to you today about how we at Amazon have avoided mechanical issues by using predictive maintenance using Amazon Monitron. Monitron's a service of AWS. Over the next 60 minutes, we're going to take away some learnings. We want you to understand why predictive maintenance matters to Amazon, and ultimately why it will matter to you as well. I want you to understand what Amazon Monitron is. I want you to understand how Amazon Monitron integrates with other AWS services. Because like AWS services, it is a building block that you can assemble into better and better solutions for yourself. And we want you to understand the benefits that Amazon gained by using Monitron. The agenda, well, like a lot of Amazon things, it starts by working backwards from the customer, understanding what the customer's needs are, and working to solve those. We're going to talk about the typical predictive maintenance processes that we follow, what predictive maintenance as a service looks like. We're going to share with you how Amazon, as an organization, integrated Monitron into their operations. And we're going to share with you what the operational impacts of that were. Some lessons learned, and then we'll open it up for some questions. Working backwards from the customer. It's a saying that you'll frequently hear from Amazon. Jeff Bezos used to use it frequently, and our leadership continues to use it today. For those of you who had your hand up and shopped at Amazon this holiday season, or have ever shopped at Amazon, this will be a familiar page. What may not be obvious to you is what you see on the right-hand side. The promise of a date, a promise of a price. This is what we call the customer promise. Customers make their selections very frequently on the basis of when a product will get delivered to them. And this is a promise that we as Amazon make to our customers. So when we tell you it's going to get delivered on a certain date, we're going to do everything possible to make sure that happens. Because until we can deliver to you on time as promised, we haven't succeeded. And the customer promise is very important to us. Now, it may seem really simple. Beautiful web page, dates and times, or predicted dates and prices are there. You click, you hit checkout, you pay, really, really smooth. And a couple of days later, boxes arrive at your doorstep. It's like magic. It looks simple. But really, it isn't simple. Behind the scenes, we've got lots and lots of fulfillment centers. And these fulfillment centers are huge. They're the size of these conference centers that we have been in combined. They're filled from top to bottom with products. It's a very complex workflow that happens to make sure that we satisfy our customer promise. All these packages, all the things that you're buying are moving around these fulfillment centers on conveyors. If you've ever been to one of our fulfillment centers, conveyors, conveyors, conveyors. Everywhere you look, there's a conveyor process to move a package, to move an item from point A to point B. One of our typical fulfillment centers will have 10 plus miles of conveyor belts, being driven by over 800 motors and 500 belts. This is what it looks like. Something's always moving somewhere in our fulfillment center. Now, your order that you place on Amazon might actually flow through multiple fulfillment centers, right? So even though we have 10 miles of conveyors in a building, your order might go through multiple buildings. So through tens of miles of conveyors for it to get from when you clicked on the website to your doorstep. If at any point in that process, one of these conveyors fails, we're at risk of failing our customer and not delivering on the customer promise. Something, again, we try very, very hard not to fail on. And to make sure that we don't fail, to make sure that these conveyors don't fail us, we have a number of maintenance strategies that we employ. I'm going to take you through these now. The first of the maintenance strategies, called phase 1, is a reactive strategy. Basically, in a reactive strategy, you wait for something to fail, and then you fix it. We say this is not recommended, because really you don't want stuff to break. You want to address things before they break. But in some cases, items that aren't critical, items that may not be readily accessible, you know what? Maybe it's okay for them to break. So even though this isn't the most recommended path, it is a process that we employ. For our next phase is the planned phase, where we will, on a scheduled basis, have our technicians go around our fulfillment centers and do measurements. Perhaps a non-intrusive measurement, checking the temperature. High temperature means friction. Friction means something may break. They may have to do invasive testing, right? Perhaps they need to actually put some probes to measure current or some other dial that they actually have to interact with. There are challenges that come with planned processes. First challenge is they're planned. They're based on a schedule. This doesn't happen all the time, doesn't happen in real time. It happens on a weekly basis, every 4 weeks, every 12 weeks. It requires humans. Requires our technicians to take time and to be deployed to do this work. The work may be dangerous. If it's an intrusive type of measurement that has to be taken, they may be in a line of being injured, right? Which is not something we want. And to prevent them from getting injured, maybe we have to stop the production line. Maybe we have to interfere with the workflow of the business. And if we do that, then there's a cost of disruption. So although the planned maintenance is a critical component of what we do at Amazon, it does have its downsides. The next phase is the predictive phase. So if the first phase was wait for it to break, if the second phase is every second Wednesday, the predictive phase is just before it breaks. It's getting that visibility that something is about to fail, and only then will we take action on it. Sounds great, but it's actually difficult to do. It's difficult to do because we're not deploying human resources to take these measurements. We actually need sensors, and we need to install these sensors. We need to wire these sensors. That's complex. And even if you had these sensors, they're collecting a bunch of data. And you need to get the data off of those sensors out of your buildings and into some kind of compute processing where you can do something with that data. And then once you get it there, well, what do you do with it? You've got to build a machine model of some sort to analyze that data. So like with many things Amazonian, we work backwards from our customers. And what our customers said to us was, we want predictive maintenance, but We want it in a managed solution that makes it easy for us to implement. Well, that's what we did with a service called Amazon Monitron. Amazon Monitron is a fully managed solution from AWS. It uses both ISO models as well as self-learned machine models to analyze your sensor data. We do this in real time, not just every fourth Wednesday. Right? We perform this in real time, and we actually provide you the managed hardware, the sensors necessary to do this data collection. Right? So it is a full predictive maintenance in a box solution, basically. Let's take a look at how it works. So on the left-hand side, you've got your operational site. You've got some machinery there. Well, we provide you with these sensors. You attach those sensors to your machinery. Those sensors, they're wireless. They're powerless. They're self-powered, meaning you don't have to plug them in. They communicate wirelessly with a gateway. That gateway, again, technology that we provide to you, that gateway will then securely transmit the sensor data over your local area network into the AWS cloud, where the Monitron solution processes that sensor data using both ISO models, as well as we learn from the signals that we get from your equipment using machine learned models, what's proper working conditions, what is not proper working conditions for your equipment. On the basis of that, we give you a dashboard, both mobile and web-based, where you can actually see the status and the health of your sensors. If in the process of all of this, something goes wrong with your machinery, right? It hasn't failed, but the temperature is starting to creep up. Maybe there's friction starting to build up. Maybe there's vibrations starting to get out of whack, right? We have a prediction that something is going to go wrong. Our model picks that up, analyzes that, and notifies your team in real time that we are predicting that something is going to go wrong. Now, the two little yellow boxes on the picture there, has anyone ever seen a Monitron unit in real life other than the picture? No? Okay. Well, I'm going to pass around some demos, because it's always fun to see web cloud technology in the physical. So you can pass these around, take a look, pass them around. What I'm sharing right now is the sensor. These are the self-powered sensors. They're wireless. You attach them to your equipment. They collect temperature and vibration readings, and they send those up into the cloud securely using the gateway. They're pretty small. They're pretty cool. They're almost non-destructible. This is what the gateway looks like, also fairly small. Once the information gets sent up into the cloud, you have access to it through your desktop or your mobile application. What you're seeing here is both history as well as current information about this device. On the left-hand side there, you'll see a list of all of the devices that I may have on my site. Some of them are in healthy status, some may be in warning, some may be in alarm. The Monitron solution is not a every fourth Wednesday kind of process. It is a continuous real-time solution. Automatically runs. You don't need to do anything. You don't need to schedule anything. It's automatically running after you've installed and provisioned your project. We're continuously collecting temperature and vibration measurements using those sensors that I'm passing around. That information is being sent up into the cloud and is being analyzed in real time. We analyze the metrics against ISO standards for the kind of equipment you have. We also analyze the metrics or the sensor data against the machine learned model that we are building in real time for each and every one of your sensor locations. Basically, with the machine learned model, for the first 14 to 21 days, we'll do nothing but listen. We'll listen to the metrics that we get from your sensor, we'll learn from those, and on the basis of that learning, we'll be able to better predict failures in the future. When we detect an anomaly, we let you know, again, in real time. We alert your technicians. When your technicians go out and do the repair or evaluation, they feed information back to us, which further creates this continuous cycle of educating our model. Okay? So we use the feedback from your technicians to better educate the model, to become better at predicting for your specific sensor and it's the machinery that it's attached to. So that's Monitron. Let's talk about what we use Monitron for at Amazon. We ran a pilot at Amazon last year. Monitron's a fairly new service. Amazon, of course, was skeptical about, how does this service work? We don't have any data. So we decided to run a pilot. We ran a pilot for 9 months. We deployed it to 33 fulfillment centers across Europe. We had 25,000 sensors deployed, 700 gateways, and in total we were measuring over 9,000 different assets. Okay? So the number of sensors to assets is not a one-to-one. Many times a single asset will have multiple sensors on it from different directions, different dimensions, etc. Here are some examples. This is a single motor, has a single Monitron sensor attached to it, fairly common. This one is a more complex assembly. I think in this picture here you can probably see about 4 or 5 Monitron sensors attached to this one assembly. Now, of those 25,000 sensors, we deployed 2/3 of them to critical level 1 equipment. And critical level 1 means that if it fails, we break our customer promise. Because if it fails, the line is going to get slowed or stopped, repair will need to be taken, and we run at risk of failing a customer promise. But we also deployed another third to equipment that is critical level 2, meaning it's important, but it's not going to break the customer promise. So why did we put it on this equipment? Well, we talked about the other processes of maintenance, right? So the planned. Well, even though things are planned, sometimes equipment is such that a human can't reach it or may not be able to reach it safely. So we deployed Monitron to those places where, again, not safe to access on your own. And if you've ever been to a fulfillment center at Amazon, those conveyor belts, they're a multi-level. Belt over belt over belt. Right? So some of those hard-to-reach places, we don't want our technicians doing maintenance on, or we don't want them doing any planned maintenance on. So we deployed Monitron there. I mentioned that Monitron is a fully managed, almost out-of-the-box solution. It has everything you need to do predictive maintenance. But it's also an AWS service. And like all other AWS services, it is a building block. And it's a building block that you as customers can assemble in ways that make most optimal sense for your business. Amazon is no different. We took the traditional implementation of Monitron and we asked our customer, well, what would you like to see? Or how would you like to see this integrated more appropriately for your business needs? And of course, our customer had a lot of ideas. The ones that we moved forward with were integrating Monitron into their existing third-party equipment maintenance software, their existing solution. So that we weren't just reliant on Monitron to notify our technicians, but we would utilize the existing third-party work order system that was already being used by Amazon. The other request we got, which we thought was interesting at the time, was can we integrate this with a chat room? Well, it turns out that within our fulfillment centers, all the technicians that work in a given fulfillment center are all part of a single chat room. And every fulfillment center has its own chat room. and the technicians coordinate their activities through this chat room. So their ask was, can you integrate Monitron with this and post into our chat room as soon as you detect something that is a warning or alarm? So here's how we did it. Took the operational site where we've got the machinery. Using the sensors that we're passing around in the gateways, we connected that to Monitron in the cloud. We still have the mobile dashboard and mobile desktop. But what we did here is we integrated with the data that comes out of the Monitron post its machine learned and post its ISO analysis. That data is readily available to you. It's your account, it's your tech. You have access to the data. Data looks something like this. If anyone's familiar with a JSON document, it's basically what it is. But this is the post-process document. So it includes information about the metrics that were collected, i.e. the temperature, the vibration levels, etc. But also the assessment that the Monitron models have performed. So it's out of ISO range, or it's out of ML range, or it's in warning, whatever it might be. This is information that becomes readily available to you. We took that information and we fed it into a service called AWS IoT Events. IoT Events is part of our Internet of Things suite of tools. Basically, what it allows us to do is allows us to model the state of a thing, in this case, the thing being the sensor, allows us to model the state of that thing in the cloud. And when we model it within IoT Events, it literally is a graphical modeling. Okay? All the big circles actually represent the state, and in this case, we modeled the 4 states of Monitron: healthy, warning, alarm, and in maintenance. But the other thing that IoT Events allows us to do is it allows us to associate actions with the transitions from one state to the other. So when Monitron says, for this sensor, which was in healthy state, is now in warning, the transition of the state from healthy to warning, we can trigger something to happen. And in our case, we triggered Lambda functions. Lambda functions are compute that we can run in the cloud without having to manage or deploy any kind of server infrastructure. And in that compute, basically a little program, in some cases not more than 20, 30 lines of code, we created our integrations to those third-party systems that Amazon wanted us to do. First, we integrated with our third-party management system. We use their API, and basically we use Lambda to push data into that third-party system, creating and or updating work orders. We also use that same integration to connect with Amazon Chime. Chime is our internal, actually not just internal, but we use it internally for our conference calling and our chat groups. And we used Chime to send a notification into the chat group that the team is monitoring. Basically, we sent a message just like this, that Monitron has determined that there's a vibration alarm on a piece of equipment, a work order has been created, and right away we see one of the technicians responding, investigated, finger guard fouled, he's going to resolve this. Right? So not only are we creating work orders, registering them, tracking them, but we're also generating real-time information to our techs, and our techs are acting on this information in real time. Now remember, nothing's failed yet. We just got a predictive warning that something is about to fail or might fail. We've notified our technicians, and in real time they're going out and solving this. So it's really powerful. Here's the overall architecture that we deployed. It's a little complex, but I want you to focus on just a couple of important pieces. Important pieces here were Monitron, the service, AWS IoT Events, where we monitored the state of that sensor, and using that state change, we triggered the Lambda, and then we used that Lambda to both connect to the third-party system, and in our case, Amazon Chime, to connect with our techs in real time. The full solution that we deployed for Amazon was completely serverless, was all event-driven. We didn't have to deploy a single server. All the services and resources that we used were all pay-as-you-go, no long-term contracts, readily scaled up from a couple of devices, a couple of sensors that we started with, up to 25,000 sensors that we ended the pilot at, and will readily scale to hundreds of thousands of sensors as we continue to grow beyond the pilot and deploy this worldwide. At this point, I'm going to ask my colleague Rachel to step up and share with us some of the operational impacts that Amazon saw as a result of this.
Thanks, Gary. So we need to think back to a time at Amazon before we actually deployed Monitron. And then what happened was we had our technicians with handheld ultrasound tools and also thermal cameras walking predefined routes, taking regular measurements every 4 weeks or every 12 weeks. And what happened there is we caught many things, right? That we saw changes in temperature before failure. We also saw ultrasound changes, and we could capture things. But we didn't capture everything. And particularly even with a 4-week interval, we could detect something was going to fail, but before we could get that downtime window to make the repair, it would actually fail. So the big difference with Monitron is we moved from these every 4-week measurements to being able to do it every single hour. And this let us, in the pilot, reduce our mechanical failures by 70%, which is really, really big. But not only did we see this reduction in mechanical failures, which meant more customer promises were met, but we were also able to plan the work in advance. So this can be things such as job in the box or kitting, so preparing the right spares at the right time, negotiating a long enough time to do that maintenance. Because if something breaks while it's in operation and customer promises are at risk, the technicians are put under a lot of pressure to repair it very quickly. Removing that pressure means that they can plan the repair in a much safer way and with the right spares and everything prepared so that it doesn't impact operations. And in the trial, we detect 4,800 failures. And we call this saving the business 20 million, but it actually saves us far more. This is an estimate in terms of repair costs, because actually if you repair stuff before it breaks, then you don't have as many broken parts to replace, and you can do refurbishment and so on. And also downstream supply chain costs, because every time an order is missed, we then have to route that order to a different fulfillment center, which is not our first choice, and therefore a more expensive one, probably further from the customer. And therefore we have to reprocess it and get it to the customer. And then there's also the chance that the customer receives their order late, and therefore they're less likely to order from us again. So there's a lot of cost associated with missing that customer promise. So what were the lessons learned during our 9-month pilot? First of all, we do have a lot of failures, and you do need multiple maintenance strategies. So yes, you can have, as Gary said, and that might be perfectly acceptable for one of these light bulbs, because there are other ones. But it's not acceptable for everything. You could have run to tells you there's a failure, and that might be acceptable for some assets. But we found for our really critical assets, we need to combine Monitron with other things such as oil sampling and current monitoring and other cycle-based maintenance strategies. What we found ultimately is an early warning system that allows for the elimination of some of our manual checks. And it's an early warning system. It's a bit like the check engine light in your car. It tells you that something is going to fail. We don't know when, though we're getting better and better at predicting that. And it allows us now to step back on walking those routes, trusting Monitron to deliver the right solution. And then for our technicians to go and work on more higher value work. As Gary said, we've actually managed to scale it to Amazon's size. We've deployed it in multiple countries, multiple continents, and we've not yet any limits. And what's amazing for me is it's completely trusted, not just by the maintenance engineering organization, but also by the operations organization. So the first question that we get asked now when we have a failure is, do you have Monitron installed and did it pick it up? And to have an ops vice president asking us that question, and then we go, oh, no, but it's not criticality 1. Well, they're like, well, it's broken and it's caused a problem. Perhaps you should go and install it. And so we're managing to install it in more and more places. And we have a very good return on investment. It's less than a year, and we're expanding this pilot now to fulfillment centers and sortation centers and delivery stations globally. And that is really about our implementation of Amazon Monitron.